Hey everybody, welcome back to Decode Tech. In this video, we're going to learn how to tell what type something is and how to convert from one type to another. And this is called type conversion. So we might want to display a number, which Python's print can do automatically for us, but sometimes we need to convert something without printing it to maybe use in an arithmetic equation or something. Or we might want to convert a string to a number, which Python's print can't do on its own. So how does this type conversion work? It does not change the data itself, but instead it creates a new thing from the original thing with the new data type that you want. So Python has some built-in functions to do this for us. Now, a function is something pretty core to every programming language, and I'm just going to briefly brush over what a function is in this video, and later in the series I'm going to have a dedicated video just for functions. But for now, a function is something with a name and then opening and closing parentheses right after it. So we've actually already used a function that is built into Python, and that's called the print function, which looks like this. Now notice a couple things here. So print is highlighted because it's the name of a function, and notice the open parentheses and the closed parentheses. Now, we've been used to putting stuff in between these parentheses, but you can just run a lot of functions without anything in them. Some you cannot, but a lot you can. And for example, if we run print, notice that between the two prompts here, that there is a space in between them. That's because print displays whatever text you have and then makes a new line. And since we didn't put any text, it just made a new line. That's why there's a space there. So you can call a function just with open and closing parentheses. So you have the name of the function, open and close parentheses. Now Python has a lot of other built-in functions that are very useful, and we're going to look at 3 of them specifically now. And the first one is called the float function, which converts something to a float. Looks like this. The other one is called the int function, converts something to an integer. And the last one is called str, and that is short for string, so it converts something to a string. A function often does something related to the name of the function. Sometimes this isn't always the case, but generally you try to name the function to line up with what it does. So a function are normally actions. They do something to the data you pass into them. And what I mean by passing into them means putting inside their parentheses right after them. All right, so let's try one of these out. So first of all, let's create an integer. I'm going to store it in a variable called d. And so an integer is a whole number. So d is going to be storing 45. Now I'm going to create a new variable called f, and I'm going to store the floating point version of 45. And how I do that is I call my float function, and I pass into it, or put in the parentheses, the data I want to convert. Now I could put 45 straight into it, but I wanted to demonstrate some other things, and oftentimes you'll want to be converting stuff that is inside of a variable, so I thought I'd just go ahead and show you now that you can put the variable name straight into the function. And we've already done this with the print function. Now I'm going to hit enter. So now we have d storing 45 and f storing the float version of d. So I'm going to prove that, and I'm going to display d, and we see it still stores 45. But now if I do f, we do 45.0 because it's now storing a float. And notice that we didn't change d, we don't change the original data. Instead, we make a new thing from the original data, which is what we're seeing here. Now we can do the same thing the other way. We can change a float back into an integer. So for example, I could take f now and change it to an int. And I'm just going to print this out. Now you don't have to use print in the interactive shell, but I wanted to show that you can put a function inside of a function. So I have the print function, and then we want to change to an integer, so we need the int function. So we need open and close parentheses as well for that integer function. And then we still put the value inside the integer function's parentheses. So I'm going to put f in there, and now we should see just the whole number 45 print out, and it did. Now one thing that can get confusing and can trip you up is forgetting to use the correct amount of parentheses when you have a function inside of a function. One trick to remember that I like is for every open parentheses, you need a closed parentheses. So if there's 2 open parentheses, that means there has to be 2 closing parentheses at the end. This will probably throw a syntax error if you forget to use one of these in a program. All right, now I'd like to talk about some errors that you can encounter with data types. And one is called a round-off error. And I'm going to use an example to show you this. I'm going to do 0.1 plus 0.2. Now you'd expect just 0.3 to be the answer, but it's not actually technically exactly 0.3. And Python stores floating point values with a certain number of bits. If you watch my How a Computer Works series, that explains what bits and all that stuff is. But basically, every data type has a certain amount of space it has to store numbers in it. And there's a finite number of bits in your computer. So a lot of programming languages define how big their data types are going to be. And it just so happens that Python has enough bits to have 15 decimal places with a floating point number. And what you can see is there is a slight precision error. In other words, there's a 4 here at the end. It's not exactly 0.3. And this can cause errors if you have multiple arithmetic equations with this that can actually add up to change the value from what you think it should be. Normally this won't be an issue. Normally it's small enough that it would take so many calculations to actually mess up a value, but this can actually cause real world problems. For example, there is I believe a US military anti-missile defense system that the programmers forgot about this error. And over years, this missile defense system got off target because this little error added up and it actually missed an incoming missile. And just saying, that's a pretty expensive mistake to make. So this is something to be aware of. In our test scripts and stuff, it's probably not going to be a big deal. But one of the fixes is then to always make sure you round off your numbers to a certain precision, maybe 3 decimal places or 2 instead of 15. So that is something to keep in mind. All right, going back to the int function. Something special about the int function is it always rounds down. So for example, when we change 45 into a float from an int, it just added a 0.0. But if you had a decimal place there like 0.5 or 0.6, it'll still round down. Normally in schools, I think they teach you to round up if it's 5 or over and down if it's below 0.5. But that's not how the int function works. For example, if we do int of 14.99 and we display it, we just get 14. Now there is a way to round up to the nearest number, but I'm not going to cover that in this video. So just know that int function always rounds down. So we've converted integers to floats and floats to ints, but you can also convert strings to integers or floats. For example, if I make a variable, I'll just call it a, and I store the string of 5, and then I say b gets int 5. Or sorry, a, which is storing our 5. So now I'm going to display a, and notice that there's quotes around it, and that means it's storing a string. So once again, we didn't change the original data, we just made a new data type. And let's print b now, and notice it's 5 without quotes. That's because it's an integer now. All right, now I want to introduce one more function yet in this video, and that is the type function. And what this does is it tells you the type of some data. So once again, the name closely relates to what action it performs. So let's try this out. So let's see if we can get the type of b now, because it should be an integer because it's storing the integer version of a. So I'm going to do type and the parentheses open and close, and inside of this I'm going to pass the data I want to check, and I want to check b. And I'm going to hit enter, and now you see you get this class int. Don't worry about the class for now, that's something we'll get into later, but notice it says it's an integer. And let's try a. So let's do type a. And that's also class string. Now note, in a program, you're going to want to do the print with the type inside of it, like this, and hit enter, and you get the same result. That's what you want to do in an actual program if you want to display what type it is, but in the interactive shell, we can just type it and it'll just evaluate the expression. Also note, just like any other function, you can pass the data straight into it. So if I just pass in a 5, it'll still give me int. So you can check what a variable is storing, or you can check what just a plain old number is, or whatever you want to check. Now there's another error I want to introduce you to that you can have with these conversion errors, is some things just cannot be converted from one type to another type with a certain function, or they might not be able to be changed at all. So for example, we have the string decode. So let's try converting that string into a number, because we could convert the string 5 into a number. So let's try float, and inside let's pass in the string decode, if I can spell it right. And you'll see we get a traceback error, and it says could not convert string to float, and they call it a value error. So obviously decode cannot be any number, so to try to convert it to a number is not going to work. But if you have a string of 5, 5 can be a number. So what is the point of all these data types? Well, computers cannot tell what something is unless you explicitly tell them. For example, the number 5, so if I type 5, that is the symbol we humans came up with to say 5 values, to represent 5 values. But the 5 itself is not 5 values, it's just a symbol representation of 5. Actual value of 5 would be like, say, 5 ones. There are 1, 2, 3, 4, 5 values. But a computer does not know this without us telling it. So a string is the symbol version, or the text, and like an integer would be the actual value version. So when you're doing arithmetic expressions, you need to use the integers, and when you're displaying text, you need to use the string format. So that's what the point of these data types are, and we're going to be working with these a lot throughout the rest of this tutorial series. So it is really good to be able to know how to use them and their specific behaviors. Alright, that's all I wanted to cover in today's video. I have a little program to test your knowledge so far. It'll bring together some of the stuff we've been talking about so far in this series. And so I'm going to bring it up on Notepad here. And the project is going to be create a program. So in other words, you have to start a new file. You can't use the idle shell. And this program is going to be to convert a temperature from Fahrenheit to Celsius. So the structure of your program will look something like this. Make a variable to store a Fahrenheit value. Use the equation 5 divided by 9 times Fahrenheit minus 32 to get your Celsius value. And then store that result in a new variable of your choice. You can name it whatever you want, C or Celsius or whatever. And then display that new temperature to the screen. And then test out your program. Try 212 to see if it equals 100 degrees Celsius, because that'll tell you that your formula is working correctly. And for a bonus, if you want, you can display the new temperature. Instead of just displaying the number 100, you could write a phrase out with it, like 212 degrees Fahrenheit equals 100 degrees Celsius. So go ahead and start a new file and try that, and once you're done, you can come back and I'll show you a little script I wrote to do this. So here we go. I assigned 32 degrees Fahrenheit to a Fahrenheit variable, and then I use that Fahrenheit variable in my 5 divided by 9 equation, and then I stored the result. So the result of this arithmetic expression gets stored back in the cell variable, and then I'm printing out cell. So I did not do the bonus in this version, and let's just run it and test it, and we get 0 degrees because 32 degrees Fahrenheit equals 0 degrees Celsius, so it's working. Then you could try plugging in 212, like I said in the example, and running it. We have to save it. Oops, I don't think I actually ran it. Let me try that again. I'm gonna hit run, and you see we get 100 now, so that is working correctly. All right, thumbs up if you liked the video. Subscribe if you haven't already for more Python videos and other computer-related tutorials. And comment down below if you have any questions or have any problems, and I'll try to help you out. And if you could share the video with anybody that might find it interesting, we'd really appreciate it. So we hope to see you all later in this series.